In this video, we will demonstrate how to calibrate the S2A LVDT signal conditioner from Alliance Sensors Group. To perform this task, you will need the following: an S2A LVDT signal conditioner, an AC LVDT to be calibrated, an LVDT test fixture with digital micrometer, a 24-volt DC power supply, a DC voltmeter or digital multimeter, and a small screwdriver. The S2A's factory default settings are adequate for most standard industrial LVDTs, and no adjustments are typically required. However, in the event that your LVDT requires different settings from the factory defaults, you'll need to configure the S2A to match your particular requirements. To perform these adjustments, carefully push in the tabs on both the top and bottom of the signal conditioner's case with a small screwdriver. Then slide the board out from the case to provide access to the dip switches and jumpers. Consult the label on the case or the S2A manual and quick start guide instructions to find the correct dip switch positions and jumper settings for your specific application. After any internal configurations are complete, begin by connecting the 24-volt power supply. Connect the positive side of the power supply to terminal 4 of the red J4 terminal plug and the negative side of the power supply to terminal 3. Next, connect the digital voltmeter, which will measure the output from the S2A. Connect the positive probe of the voltmeter to terminal 4 of the J3 green terminal plug and the negative probe of the voltmeter to terminal 3 of J3. When connecting the LVDT, attach the primary high of the LVDT to terminal 1 of the J1 black terminal plug and the primary low to terminal 2. Then connect the secondary 2 high of the LVDT to terminal 3 of the J1 black terminal plug and attach the secondary 1 high to terminal 4 of the black plug. The 2 remaining secondary wires must be connected together and can be attached to terminal 1 of the J2 blue plug for convenience if the leads are long enough. If you're uncertain about the LVDT connections, make the secondary connections using the 2 magnetic dots as your guide. If the connections give you the wrong directional sense of output, interchange the 2 primary connections or flip DS23 on the S2A signal conditioner's PC board to on. For this demonstration, we'll be using an LVDT with a plus and minus 0.5 inch measuring range, which the S2A recognizes as a total measuring range of 1 inch, along with the S2A's default analog output of 0 to 10 volts DC set with DS14 turned on. Now with all the connections made and the LVDT positioned into the test fixture, we will apply 24 volts DC power to the S2A. The red power LED on the face of the unit will illuminate, indicating power is present. The green P LED will illuminate as well, indicating that the S2A is operating as a standalone master. It is important to allow 15 minutes for the S2A to fully warm up before proceeding with calibration. With the S2A fully warmed up, we're ready to place the S2A into calibration mode. This is accomplished by pressing both the full scale and 0 buttons simultaneously until the red power LED begins to blink, which indicates the S2A is now in calibration mode. Using the micrometer, adjust the LVDT's core position until the S2A's 0 indicator LED glows solid. This is the null point of the LVDT where the core is at the center of its stroke. Now reset the digital micrometer readout to 0. Next, using the digital micrometer, move the LVDT's core inward to minus 0.5 inches. This will take us to the negative end or 0-inch core position of the LVDT stroke and will be the S2A's 0 volts DC output position. Enter the 0 point position into the S2A by momentarily holding the 0 button down until the positive indicator blinks once. The negative indicator will now glow solid and the positive indicator will begin to blink. This shows that we have successfully set the 0 point position. Do not pay attention to the S2A's DC output while performing a calibration. Now reset the digital micrometer readout to 0. Next, we move the LVDT's core outward by 1 inch. This will take us to the positive end or 1 inch position of the LVDT core's stroke and will be the S2A's 10 volts DC full scale output position. When that position has been reached, momentarily hold the full scale button down until both the positive and negative indicators illuminate solid. This indicates that the system calibration has been successfully completed. Finally, to return the S2A to its run mode, press both the full scale and 0 buttons simultaneously until the red power indicator glows solid. The measuring system is now ready for operation. We can now observe that the DC voltmeter displays an output voltage of 0 volts DC from the S2A with the LVDT's core at the 0-inch position and 10 volts DC when the LVDT's core is at the 1-inch position. Thanks for watching this instructional video. If you enjoyed this video, please subscribe and click the bell to turn on notifications. If you require additional support, please visit our website, alliancesensors.com, or call us at 856-757-0250. Our experienced application engineers are standing by to help find a solution for your industrial measurement requirements.